All right, in this lesson, we'll explore some mathematical methods that are available on our floating point objects. In other words, our numbers that have decimal components. So let's take a look. Let's do a quick review actually of the 2i method that we introduced a little bit earlier in this section. If I have a floating point number like 10.5 and I call the 2i method, that's short for to integer, that's basically going to chop off the decimal component of this number and just give me back 10. It doesn't matter how high the decimal component is. For example, if this is 10.9, it's not going to change the results. It's still going to be 10 right here. So it's not rounding, it's simply chopping off that decimal component. And if I call the class method on my resulting object, we can see that it is in fact a fixed num, so it's also converted it to a fixed num or an integer object instead of a float object. All right. Now let's take a look at 4 brand new methods in this lesson. Let's begin with the floor method. The floor method rounds the floating point down to the closest integer. So in many ways, it functions basically identically to 2i. So if I do 10.5.floor, it rounds it down. You can always remember that the floor is down. It's beneath you. So it's going to round the number down to the closest integer. So that way we're going to get 10 when we do 10.5.floor. And just to prove this to you, it is also giving me back a fixed num. So it is changing the type of object that we're getting back. So what is the opposite of the floor? That's the ceiling, and the ceiling method has the name .ceil. So it's a little bit abbreviated. But if I do 10.5, same floating point, and I call the ceil method, that's the ceiling, so it's going to round up to the closest integer. So 10.5 is going to round upwards to 11. We can see 11 appear right here. And just like in the previous example, this is in fact a fixed num. Ruby has converted my floating point number to a fixed num. Let's remove this class method for now. And let's explore a few more methods that are available. We have the round method, which rounds the numbers in a floating point number to a given precision. That means a specified number of digits. And round is actually an interesting method because its argument or its input is optional. So let's take a look at what happens when we both give it an argument and do not give it an argument. Let's say I take pi, which is 3.14159. That's a good, healthy floating point number. If I call the round method on it and do not give it any kind of input, what it's going to assume is that I want to round to 0 digits. And generally, when I want to round to 0 digits, I want to get an integer back. So this is going to do something very similar to what we've seen with our other methods. It's going to round this to 3. But here's where it gets a little bit different. This method is following the traditional rules of mathematical rounding, which is if something is below 0.5, it rounds down, and if something is above 0.5, it rounds up. So if I were to change this to 3.6 instead of pi, and notice I still have the round method without any inputs, this time it's going to round to 4. It's going to round up because 3.6 breaks that 0.5 threshold, if you remember from grade school mathematics and basic arithmetic. All right, so in addition to our round method without any actual inputs, we can provide an optional argument here. Let me go back to pi with 3.14159. And if I provide an argument, I can do that in parentheses or without. Let's do it with parentheses. That's best practice. This specifies the number of digits that I want to include. So if I want to include only 2 digits after my floating point, what I can have here is 3.14. It's basically rounded and only kept the first 2. If I instead replace this with 3, what we're going to get this time is 3.142. The reason is when it gets to this third number, it notices that we have a 5 in the next position, so it's going to round up in that case, and we're going to get 3.142. Similarly, if I put in 4 here, it's going to keep the first 4 after the floating point, but that last number, 5, is going to be rounded to 6 because immediately following it afterwards is the 9, which gets rounded up. So we're going to get a value here of 3.1416 with the round method. Notice here with all these iterations of the round method, we're getting back a floating point number. That's in comparison to the first time we called the round method, which was without an argument, we got back a fixed num. So in this case, it's a good example of how the arguments that are supplied to a method can even determine the object you're going to get back from Ruby. Let's conclude this lesson with one more method. It's the abs method, which is absolute value. You may recall that for mathematics that the absolute value represents the distance of a number from 0, and the advantage of absolute values is that they're always going to be positive. So if I have a number like 35, let's actually make it a float to begin, 35.67, and I call ABS, which is the absolute value method, we're going to get 35.67. That's the distance that that number is from 0. If we reverse this by putting a negative in front of it, now it's negative 35.67, the answer is not going to change. So this is particularly helpful when you always need a positive number. Whenever you're measuring something like distance, for example, which is always positive, or area as another example of something that is always positive, many times a method like this can absolutely help. It depends on what your program's doing and whether it's requiring such mathematical operations, but the absolute method can be effective there. And the absolute method here, the absolute value method, the ABS method, can also be called on integers as a matter of fact. So if I replace this with simply 50, let's say, we're going to get 50 on the right. If I replace this with negative 50, we're going to get 50 still. That's the distance that that number is from 0. So that's a quick introduction to some methods that are available on floating point numbers. Again, just to get you familiar with the syntax of calling methods, getting a sense of what methods are available on different objects, getting a bigger picture and a general sense that some methods are available here but not there, some methods are available elsewhere but not here, and so on and so forth. It's really just a matter of seeing everything that we're working with here as an object and methods as simply messages that we're sending to those objects that tell it what to do. If an object cannot receive a specific message, then it's going to trigger an error. If it can, then it's going to process it and give us back a certain return value or a result. So that's an introduction to methods available on floating point numbers.